Okay, so welcome back to our next session. Today we'll continue discussion about dictionary. Yesterday we talked about dictionary, but we stopped somewhere else, so we can continue. So we already discussed that dictionary is one of the most important Python data structures, and we can use these curly braces to actually create dictionary. And yeah, so this is empty dictionary without nothing inside, but this is a dictionary with content. So this is called a key, and this is value. This is a key, this is value. So when we run this, when I say give me this one, so it means here I have my dictionary. So dictionary can be actually used to implement a real world scenario with a lot of stuff. So how can you do like an insertion, access element in a dictionary? So for you to access element in the dictionary is we use this convention, right? But as I said yesterday, this convention, if it is a list, will actually override the content, right? So here in the dictionary, what we do is we are adding another. Yeah, here if it is a list, because this is a list, this override the content, right? Override the content. But if it is a dictionary, this means that when we do the same way, this will actually add an element to the dictionary. So this is what we discussed yesterday, and yeah, just recapping. So you can see we had an element here, and also here this is actually to access item B. So when you put the key here, it means you are accessing the value here. You can also check some stuff if they exist in the dictionary, but particular key. So here we say B in D1. This will check if B is actually a key in D1 dictionary. So this is another way to check. Do you have that key? You can also delete a key. Delete some stuff from a dictionary, right? So here, let me add other stuff. I have some values, and I have added another stuff called dummy. And when I want to delete, if I know the position of item, I can put the position. So here I put delete 5. It means I'm deleting something here. Can you see that? This is the key. Delete 5 is the key. Now some values will be deleted. Also, you can use drop pop method, but the difference is that the pop method actually returns what has been removed, the value. So, but delete, remove the object in its entirety, but the pop method actually returns the object that has been removed. Yeah, so when we run this one, we can see that the object, we already now remove everything. Yeah, so if we want to also look at the keys in the dictionary, we can use the functions key, as we already know that because D1 is a dictionary, when you use dot, you will see a lot of method related to that object. So this method is a key, yeah, right? So we want to use a key, and the key method basically return the keys associated with that dictionary. So you can see here we have keys associated with the dictionary. Yeah, so this one you can see here actually gives dictionary iterator. Yeah, we can use list to convert the result, because you can see this is dictionary form of generator or iterator. Can you see that? So this output, if we want it to really return a list, right, we can use this something list on the return value. So you can see, if we want it to return a tuple, we can use the function tuple on top of that. You can see it returns now a tuple, right? Yeah, so we have another function called values, a dictionary. So values actually return both the key and value, both the key and value. So when we say return this, you can see here, it actually return the key. Values, values, not items. I want to say items. So values return the values in the key. So here we have some values, but the key return the key. But there is a function called item. So when we say the d1.item, so this will basically returns the dictionary key and the value. Items, I think is this right? Items. Yeah. So you can see here it returns the dictionary keys and value, right? So we can use this function. So in a nutshell, there are many other methods that can be used to this stuff. You can see them here. So one who can actually, for example, set default can be used to set default of a dictionary. If, for example, you try to access a dictionary, but an item is not there, you can set a default value that if a value is not available in a dictionary, the default value can be returned. So there are many methods that are associated, and one can basically come as a custom with that. Or if you try to solve a problem, you say, how can I do that? And you can become aware of that. We can also match a dictionary with another one. If we have a dictionary, existing dictionary, we can use update. So you can see here. So you see in a list we use extend, right? In the use we use extend, but dictionary we use update. So here we can update the dictionary. Yeah, so that's a lot of stuff we've seen in the dictionary. Any question before we continue? Any question before we continue? Okay, so if there is no question, let's continue. So creating dictionary from sequence. So yeah, so this is now we have seen one way to create dictionary, basically by using either single brace, square braces this way. So yeah, by using this to create a dictionary, right? But let's look at another way to create a dictionary. So creating dictionaries from sequences. So you can basically create dictionary from sequences. So what this means is that since dictionary essentially is a collection of two tuples, the function accepts a list of two tuples. So here I can have range, and I have another tuple, and map to dictionary. I can create another. I can create a dictionary with that. Valid key types. So now, does that mean in a dictionary, can we have everything to be as a key? So what I mean by that is, like, for example, let me see this. I want to create a dictionary like this. So here, maybe A is this. Maybe I want to have two items in the dictionary. A is equals to 2, and B equals to, B equals to 3. No, 5 is a key. Is equals to maybe B. So here you can see when we run this, you can see we have a dictionary, right? In this dictionary, we can see basically that the key here is a string, right? And the key here is an integer, right? So it means you can use both the key integer and can be a key. But what about if I say, okay, my key to be a tuple, for example, 1, 2. You can see this is a tuple, right? Can it be? Let's run this. Yeah, you can see a tuple can be a key. What about a list? Can a list be a key? So when we have this, a list, can it be a key? Let's run this. Yeah, no. So it means that valid keys types, there is what is called the key that is valid. There is a key that is not valid. So the values of a dictionary can be any Python object, but the keys, the value here, the value of dictionary can be anything. So here it can be a dictionary, can be a list, 1, 2, but here let me change it to be 5. So you can see in this case, you can see in this case, the value here is a list, and here key is a string, but the keys, they have some kind of restriction. Value can be anything, but the key must be something that is immutable, that cannot be modified. That is the idea. The key must be something that is not mutable. What are some of the stuff that are not mutable in Python? Who can tell us some stuff that are not mutable that are immutable in Python?
Tuples.
Yeah, tuples, exactly. So tuples. So it means that I can have, but list is a mutable, right? List, you can modify a list. For example, I have this list. If this is A, I have this. I can say, okay, I can modify A of 0 equals to 5. And when we run this, and I said, okay, give me my A, show me my A. Yeah, we can see we can modify a list, right? But if this is tuple, so if this is tuple, you cannot modify it. This is called immutable. or if this is what we call a set, will come. This is a set. Set is used the same way we create a dictionary, but it just like a list and tuple. Set use this curly braces. So what about the set? Can we modify? No. So this means that the key in a dictionary must be valid, must be a valid immutable object. So if you use, for example, if here I use a list which is mutable, then this will give me an error. So this is the idea. So what do you mean by something that is mutable? It means it has a hash value. So for example, string, this, if I do this, it has some kind of hash value. This means that this can be a key value. So when I can change this one to be this as a string, when I have this means that this is value. So what about this one? Here I have a tuple. Can you see that? So this is, it has a hash value, it's valid key. What about this? Because this is, okay. Yeah, so this means that this is a list. There is a list inside, so it cannot be a key. So the idea we want to press here is that whether you are creating a dictionary, the key must be immutable. If you have anything as the key that is mutable, it will return an error. Yeah, so sometimes you may want to use a list, your list to be a key. So what you need to do is just change it to tuple. And now, yeah, so for example, now here I have an empty dictionary. Can you see that? Empty dictionary. Now I have, or you can change it to tuple or dictionary. So here you can see a list, and now I change it to tuple, and now I assign this, the tuple becomes a dictionary, right? So here you can see hash is valid key. I mean, tuple is valid. What about this? Yeah, hash of 5 is also valid because a single number can be a key. So in a nutshell, what I'm trying to press here, you can read more about it, is that the key must be something immutable. Any question before we continue about what dictionary is? Any question? Okay, right. So the next thing we want to see is called a set. So a set is basically an order collection of unique elements and also immutable. Means you cannot modify its items. And you can set, you can create a set in 2 ways. Number one, you can use this function, just like a list. We can use something like this, list, to create a list of items. We can have, for example, I can have 1, 2 to create. You can see here, for example, what about this? If I use this, no, okay. This, yeah, you can see I create a list with this. You can also create dict, right? Dict with this keyword. You can create a tuple with this keyword, tuple. You can create now a set with this keyword as well. So all this keyword or function can be used to create all those data sets. So here I can create a set with this one. When I run this one, this will actually give me this. So a set, the content of a set must be unique. So set, remember, in our undergrad, set contain unique element. Okay, set must contain. So you can see here we have 2, 1, 2, right? 2, we have multiple 2, it will return only 1. We have 3 guda uku, view, can use that. So a set gives you unique item in the list. But you can also, not with this keyword set, but you can also use this curly brace. You can see open and close. When I run this one, this will actually give me this. So this is called a set, and it has a lot of features that you can use. And set has also inherit all other features that you know in mathematics. For example, union. So I can put the A union B to give me this. So this is called union, right? And also you can use this either this. So this is what this is also union, right? So you can use this or this. But we can also use intersection with this keyword. So this gives us intersection. And this also gives us intersection as well. So this is intersection as well. This is intersection. This also is intersection. So That is called some operation with the set, but also set has, you can use some what you call in place operation, in place. So what this means is that, let me create a list, so here, for example, I copy some element, I copy from A to C. Now let's assume we have a variable called C, and the C contain 1, 2, 3, 4, 5, right? So this thing, you can actually perform this set operation using in place. What does that mean? So it means that here, when I run this, I'm trying to perform what is called intersection, but you can see this is not the same way as I did here. You can see A, this is called union, right? A union B. Can you see that? So I can assign the value here to C, to M, something like this. And when I call M here, I can say, okay, A intersection B. You can see the result. But we know what is called in place, right? So here it means you can actually you can perform these operations in place. It means here C intersection B without trying to modify anything. So this is the something. It's just some kind of operation that you may see. This is called in place. Also, like dictionary, a set element generally must be immutable. So here you can see here I have my dictionary here. Okay. So you can see just like like a dictionary keys, a set element generally must be immutable. So you can see here, set element here that we have is a list, right? So this means that this will return an error because list is mutable. But what about if we change this operation now, changes to, if we change it to, for example, to this from list to tuple. Yep. So you can see this is tuple, right? So when I run this, you can see this give me a set. So this means that more or less that we see that in dictionary, the keys must be immutable. So also in the list, the element, it must be immutable. Yeah, so you can also check if something is a subset. So here you can see I have A set is equal to this. And now I want to check whether these items are subset of A. It means they are contained in A. So I can run this one, and this will give me the true if they are subset. Whether if also A set is a superset of this. We all know this operation in mathematics. Superset, it means it is I mean, I don't know, what do you call, what is the best word in English to say a superset? Parent co?
Yes, yeah, it's like the parent set, yeah.
Yeah, like a parent set, something like that. So we all know this. So these are operations. Set are also, you can check to see if they are equal using equality operators. So these are some of the stuff we have seen now. Now we have seen a lot of other stuff related to operation for list, dictionary and set. So now we cover the list, we cover dictionary, we cover sets operations. Yeah, so any question regarding these ones before we move into operations, list and comprehension and some stuff? Okay, so if there's no question, these are just the background. Remember, we are just revisiting our Python stuff, right? They will really, really be useful when we move into the main data analysis, and also if we move into our more deep learning stuff. Please just try to practice them. I think I will reinvent our daily practice, Python daily practice. Falalu, ya kamata daily practice din nan mu da shi. Haris, ya kamata a dawo da daily practice din nan so da mutane su dinga practicing din Python skills su kasu manta. Ko ba haka ba? Yau project ba ko project ko?
Project ya kamata a
yes, exactly. Yes, so maybe follow me da Allah, follow me da yanda za mu yi creating din project, ka tuna mun kan na manta yanda za a creating project, yanda za mu abin nan. Har sai kuma follow me yanda zan dinga share
design din project din.
Na?
Zan yi design sai mutane su. Zan yi design din topic.
Yawa. So da akwai I have existing project na zan share. that we can practice along. Yeah, just let's continue. And I will revive also our daily practice Python. Harris. Yeah, you remember our daily practice Python, ko? Then you reviving this, you will keep us motivated every day. Misali, just one problem, which is solving is a good idea. Yeah, remember me, please. Yeah, thank you. Okay, let's continue. So let me explain now one good thing about Python, which is very elegant way to do iteration. You will see this a lot when we come to our Python data analysis. So it is important that you learn this very well. So let's look at a motivation before we go to the comprehension. Assume we want to create a list containing the first 10 square numbers, right? So maybe in a Sunday creating one list. So I create an empty list. Now I want to go for the this, and now you remember append will add something to a list. So here for I in range, we know range is from 0 to 9, right? Range 10 means 0 to 9. So for I in 0 to 9, I create something square, which is empty here. Square dot append I times I. It means here that okay, for I in range from this means this is a list is a list contains 0, 1 up to now 9. Come to I range go. Let me, you can see range. If I call range of 10, you can see this will give me basically this will give me the list of yeah, you can see this give me 0 to 10. So this is a range, but this thing the 10 is not included, right? So let me call a list on top of this stuff. When I call a list on top of this guy, and we can see here what this guy give us. You can see it give me 0 to 9, right? That is range. So this means that we are going through for I in range, that is from 1 to 1. The first one is 0. Then you can say 0 times 0 is 0, right? Then append, it will add it to our list. It will go back to the next one, which is 1. So it means we are printing the squares of a list, right? 0 square, 1 square, 2 square. This is it. This is using for loop. Now, the idea is this is actually takes a lot of space to write this code. Why can't we use some kind of elegant way? So Python comes with something which is better, which is elegant. We'll see that in a bit. Another thing here, you can use what is called map as well, alternative way to do that. You can use map. For example, here, an example, consider a situation in which you need to calculate the price of tax for a list of transactions. So for example, here, I have a list of transactions here, 1, 2, 3, can you see them? And now I have the rate for the tax. Now this transaction, I want to find the tax for it. This, I want to find tax for it. Now I can write a function here. Can you see this function? And now I say return this stuff like this. And this is basically using a for loop. Yeah, so here it means here I write a function here. I can use map. So a map will take a function and apply it. So this function, what this function does, we can see this function, what it does basically, get price, you put something, it return tax rate, the formula, how to calculate that, those formula for it, it basically do the calculation. So it means that we can take map and which actually take this function and apply to each value in transaction. It will take the value and now calculate the tax. So this is something called map that you may see it. So map is basically take just like mapping. It will map this function to any other stuff value here you have. But this is not the main idea we want to convey. Let me go directly to the idea I want to convey, which is basically list comprehension. So list comprehension is a way actually to make a list. So we can see here, we make a list using for loop. We make a list here using map, but the best way, another way, the third way is using list comprehension, which is basically a good way to make that. So let me take this example that we saw here, this guy. So this guy that we saw here, this is how basically we create the list. No, not you. This one. So this is basically how we create this. Am I not copying? Okay, let me use manual way. Okay. Okay, so you can see this is a follow, right? This one we create a square, but there is something called list comprehension that can be used in a one line to create, instead for us to do this multiple line, a one liner. So this is how to do it. This is the format. You say for member in iterable, then return what is here. This is a keyword for member, that is the item you want to iterate in. The member in iterable, anything that is iterable, like a list, like a tuple, like a dictionary, because the iterable, return this. So here we can say for, can you see that? For I in iterable, this is iterable, return items I, which is a square. So this is how we do it here in using for. We create an empty list, and now we say for I in this range, append anything added here in the empty list, append, update it, and now it keeps circulating. But in a single line, this is how we do it. For I in range of that, return this. So this is expression, means something that means something that anything that will be returned, but this is it. So for every list comprehension in Python, so when we run this one, will give us the same answer with this. Can you see that? The same answer with this one. So for every list comprehension in Python includes 3 elements. So for every list comprehension, it contains at least 3 elements. The first one we say expression is the member itself. When I say the member, that is member inside this list. The member inside this range are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is, they are called the member. So here, what is it? For member, that is anything inside iterable, return expression, some expression whatsoever. So here you can see for I is a member in range. That is for I. Any I can is 0, 1, 2, return expression, I times I, member times member, which is 1 times 1. So expression can be anything. We will see more a lot about that. So here, expression is the member itself a call to a method. It can be a call to a method. For example, I say, okay, maybe I have a method called, let me use this guy. Let me use this guy. Import
method square.
Import math, right? So maybe I can say math dot maybe sign of I, something like this. So here can be anything. So here when I run this, can you see it? Yeah. So here can be anything. When they say expression here, expression, what is expression? Look at it. Expression is a member itself, a call to a method. What they say, a member itself, it means you can return a I only. A member itself. So I can return I, that is a member itself, a call to a method, or any other valid expression. What do you mean by valid expression? A Python, komai idan kai addition, multiplication, subtraction is valid expression. Any valid expression that return a value, square, whatsoever, in the example above expression is this, is the square of the number. I don't know if you understand what I'm saying. Any question? If you are confused, it's a little bit confusing, list component, but if you understand it, answer it all. Now, member is the object or value in the list. Can you see that? Member is the object or value in the list or iterable. In the above example, the member value is I. Iterable is a list. So what is iterable? Iterable, something that can be go in iteration. We'll see what we mean by iterable in the couple of next session. It's a list, sequence, generator, or any other object that can return its element one at a time. Anything that can return its element one at a time. In the example above, the iterable is range. So kunsa range yana return the element is one at a time. So it can be a list, a set, or sequence, or generator. So that is something. Yeah. That is basic list comprehension. The basic one, look at the basic. So I can show you more about that. But the basic is this: for member in iterable return expression. But you can do a lot with list comprehension. Number one, you can do filtering. You can filter something. How can you do filtering? For you to do filtering, it has its own format. The format for doing filtering is this. You said, okay, for member in iterable, you put some condition, then you put the expression here. For member in iterable, you attach a condition, then you put the expression. So what is the difference between the previous one? Here we put some condition. You can see here there is no condition, right? Just expression. So let me show you an example what we mean by condition. So for example here, given a list of string, we can filter our string that with length 2 or less. So here I have a string here. Can you see ASS? So I want to filter out item in this string that have length greater than 2 maybe. Or something like that. Right? So in this case, and I want to also, if I filter them, I want to change them to uppercase. So in this case, I will say for X in string. So you see for X, S is the member in string. What is this string? If, can you see this is the condition? Can you see if string is the iterable, in is in, member is X, 4 is 4. This is the condition. So we know condition in Python, right? If this is a condition, right? Using if. This can be any condition. So if length is greater than 2, it means it will not return 1. It will not return 1. It will return those stuff, that is the item, the member dot upper, that is uppercase string. So who can tell us what this will return? Who can volunteer to tell us what this will return?
It will return batch.
Okay. It will return what?
And Python. Batch.
Yes.
Dog and Python.
Yes. Can you see that? But in caps, right? Yes. So you can see this is what it returns. So this is, you can see here, we do filtering, right? We do filtering. So it means that you can use list comprehension in a very good way to actually do filtering. But as you can see here, you don't actually do filtering. You just use the for loop instead for you to just do that, right? So this is another example. Example, filtering out character and sentence that are not vowel. So here, maybe here we have a sentence, and we want to check into this sentence and say anything that, any character that is not vowel, we want to discuss it. So let's start with it. For I in sentence, so you can see for I in sentence, I is the member, sentence is our iterable. If I in this, that is if I, that is member, is inside this, then return the member. Right? So who can tell us what will happen here? What will be the output? What will be the output here? Who can tell us? Okay, so you can see what this means is that anything that is inside, if things inside this sentence, they are inside this, then return them. So here you can see T, because it's not a member here. We know what is in, right? In Python, in means something that is inside belongs to this. For example, if I have these are called membership operator. If I have A is equals to Musa, then I can say M in Musa. So this will return true if that is correct, right? Oh, I have missed it. I have something. Or something like this. M in A. What did I say? Okay, let me just make it simpler. Maybe we can have this. I think, so this is called membership operator. So membership operator basically try to see if something basically is inside stuff. So here what we are trying to see is if I is this, so this is what it is. So yeah, so this is called list comprehension, but also you can use it as a dictionary comprehension. You can see the same structure we saw, but this you can see is key and the value of dictionary. Then we have for value in collection with condition. Can you see that? The same thing. So you can see that you can see here for what we saw here. This you can see this is used square bracket, right? Square. This means it's a list. But If it is a dictionary, you can see it, you can have these curly braces, and what it returns will be like a form of key and value pairs. It can also be like a set. You can see a set is used with curly braces, and yeah, so this in some ways, but most naturally we use list comprehension, but you can see also dictionary comprehension or set comprehension. So yeah, any question before we continue? This is also another example that just try to see that it returns the length of the length of each item, right? So here you can see for X in string, for X in string, what is a string? This is a string. Return the length of X. So for object in string, return the length of the object, which you can see is this. So this is basically what we, yeah. Any question before we continue? This is an example of dictionary. Yeah, so this is an example of dictionary. So you can see here we have for index value, enumerate this. So this is enumerate, which basically check the index and also the value, then return the value and index. So this is something that you always see. Yeah. So this we now see two types, just normal list comprehension. There is another type which is called list comprehension for updating values. So what do you mean by that? So for example, if I have this list, I want to iterate over this list to update its value, not to filter it. Or like this one here, where you see we basically go to this list and now filter, remove some stuff that we don't actually like. That is where we put the condition at the end. And we use this format. This is the definition. This is the expression for member. We put condition at it. What about if we want to change the members? We don't want to filter the members, but we want to update the members. Then this is how you do it. This is the, yeah. So if you want to update the members, then you put the condition immediately after your expression. So remember in iterable expression, something like that. So let's look at it. If you have a list of price, then you may want to replace negative price with 0 and leave the positive value change. So you can see here, we have a list here, but we are not trying to actually remove, filter some price, but we want to update the price. Anyone that is negative, we put 0 instead of replacement. So we use this. So this is how we can do it. So you can say for I, which is member, in original price, return I. Can you see? But if I is greater than 0, else, this is the condition. Can you see? This is the condition. For I in original price, return I. But here we have condition. Can you see the condition? If I is greater than 0, else, if I is greater than 0, return I. If I is greater than 0, but returns, else returns 0. So if the member is less than 0, is greater than 0, it will be returned. But if it is less than 0, it like minus, so the 0 will be returned. I don't know if this makes sense. Do you understand this? Does this make sense?
Yes, sir.
Okay. Ask question, please. Any question? Malam Amurja.
Yes, doctor.
Kin gane ko abin da ake nufi?
Ai mun yi wannan da kai ko?
Yawwa, ashe mun yi ke wancan. Yeah, a wannan littafin. Yeah. Okay. So nested list comprehension. So there is another one called nested list comprehensions. So nested list comprehension allow us to do many lists. So let me show some stuff. Here we have a list here, right? We have a list. We have 2 lists inside here. I have this another list inside a list. And here you can see I have, okay, this is nothing. Okay, this is not an item, I think. Okay. Right. So nested list comprehension. So what's the meaning of this nested list comprehension? So you can see here, I have list, right? One list, and I have another list, right? So I have like nested list inside another list inside list, right? And we want to do list comprehension. If we want to use using for loop, this is how to do it. You have so suppose we want to get a single list containing all names with 2 or more A's in them. Look at the problem. We have a list here, all data. And suppose I want to get a single list containing all names, about names from one list to one list, with 2 or more A's in them. What means with A appearing 2. For example, yanzu one list ne da yake da 1 or more A, 2 or more A ana. Maria. Don kuma me?
Natalia.
Natalia.
Natalia, yawa.
Yeah,
so you see now here we want to get a list, one list da yake. So, but this is a list of lists. So we have what is called nested list comprehension. So here for us to work on this list, we need to work on what is called nested list comprehension. So if you want to use for loop, that is how you can use with for loop, for example, but we want to use nested list. So this is how you use nested loop for. So this is how it is work. So look at it. For names in all data, can you see that? For names in all data, so names is the object, is just member in all data. For names in all data, and for name in names, that is object in the Katako from all data. If name.count, if name.count A is greater than 2, then return the name. So that's why this return this. So this is a little bit confusing, I know, but with time, yeah, you can see even the author said that at first, nested list comprehension are a bit hard to wrap your head around. The 4 parts of the list comprehension are arranged according to the order of nesting, and any filtering condition is put at the end of this. So it's put at the end as before. So this is it. Let me explain before. Now we have 2 lists. We have 2 lists. I have a list of lists, and this is a list inside and another list. And I want to create a single list wanda yake dauke da gaba ɗaya sunan mutane wanda amma a cikin sunan mutanen wanda only one does have A appears twice. Now how can we do that? So we can use nested loop for nested list comprehension. This is the first one. This is the second one, right? And the last part is you put your condition. So what the first one does? So the first one, what it does is this. For names, can you see? For names in all data, meaning for names in all data, that is all the names in gaba ɗaya nan wajen, for all names inside, for all this one here, then where is it? For name in names. So it means for name in names. Now it's trying to see for any name inside a single list. Then if name.count, so here it means name. Oh, no. Here means name is a single item inside that thing. So if the name.count is greater than 2, then return. This is something that it's I think it's a bit difficult to understand, but the book also explain it. But if you practice, you can get the idea what it means. But here I have another example that maybe let us understand more. Here is another example where we plotting a list. Okay, so here in this one we plotting a list. So here you can see I have tuples. You can see I have a list of tuples. I have one tuple, I have another tuple, I have another tuple. But what I want is I want to have a single list with all these numbers. It means I flatten it. So what I can do is this. For top in some tuples, this is member in this. So this is for tuple in some tuples. For any tuple in some tuple, that is for anyone, this, and for X in some tuple. So X means member in tuple. Just look at it. This is very cumbersome. So let me explain it again. For tuple in some tuple, it means for one, each one, this means this. This means this top is referring a single item inside the list. No, okay. Because you can see top means a single. One. That is for top in some tuples, then I want to go inside this one. Then I say for X, can you see for X in top? That is for X. X is a member in this tuple. Return X. So this is basically, we'll try to go the first one for top in some tuple. What is the first one? This is it. Then for X in top, that is, it will say 1, it will return 1, it will return 2, it will return 3. Then it will go back for top in some tuple for this one. For X in top for 5, 5. So that is, it will just flatten them. So this will give us a list with all the items. I know, yeah, any question? This is a little bit hard to wrap around, as they said. Any question, feel free to ask question if you don't understand, or anyone can explain better, in better way. Any question? Na san ba gane ba, akwai wanda bai ce ni ba gane ba gane ba.
I think what you need to explain is the order of execution.
Yes. Yeah. So yeah, there is some order. Yeah. If you look at this one also, at there is order. Yeah, there is what we call order of execution of the nesting. So what we mean by this order of execution of the nesting is this. We have 4, which is the first 4, and I have another 4, the second 4. The second 4. Then the first 4, the first nested will actually take one item. Then if it takes the item, then it will iterate to this. It will take the next one, and the next one will go inside the list and to the remove it. So for the first one, for tuple in some tuple, which is tuple, a single one. This is some tuples inside a list. But for the first one, for tuple in some tuple, the first one is this. Okay, this is this one. Say Akachi, go again. For X in tuple, that is for any item, a single item inside this, return it X. So they for any item you return it, they from the next one. So this is how it works actually. Yeah, so keep in mind that the order of the expression will be the same if you wrote a nested loop. So you can see if you have the nested loop this way, it's still the same. So this is basically what we mean by nested tuple. I have some other example here you can practice, but the idea is still the same. Yeah, I have more example I put here, but the idea is still the same. Any question? We need to move on. Yeah, because I know it's a little bit confusing, but yeah, if you practice, we'll share more practice exercise than you. Yeah. Any question before we go on? So this means that we have seen list comprehension, which is very, very important in Python. It's an elegant way to Pythonic. They say this is Pythonic way to do some stuff in Python. So please, yeah, take note. So let's move on with the next item, which is what is called functions in Python. So functions are one of the greatest thing to actually allow us to write very concise code. So as Hadley Wickham, one of the R programmers, because I love R, I do R a lot. That's why I know Hadley. So he said, you should consider writing a function whenever you copy and paste a block of code more than twice. Yeah. So when you have some kind of repetition of code, you copy and paste the same code twice, then don't do it the third time. Just write a function so that you just be calling the function to do that stuff. All right. So this is it. So let's go on with remember how to create a function in Python. So for you to create a function in Python, this is the way. You use this, which is called def. Def is a keyword to create a function. Then this is the name of a function, and you put some stuff inside. These are called arguments of the function, and now you put whatsoever you want the function wants to do. So this is basically a function that do some kind of addition. So if I want to create a function that add the numbers, I can say def sum. I say okay, sum of the number A give B. Then I can say okay. This one here, and you remember what the function does, summation. I can say okay, the function basically returns sum. I can say okay, return A plus B, right? So you can see now here I have a function which does some numbers. When I have this 3 and 4, 3, 4, this will actually return the sum of 3 and 4. Yeah, so this is how we create a function. Use def keyword, use sum. Sum is the name of the function. These are argument, and whatsoever comes inside here, remember, is the content of the function. But remember, you cannot have this in one line. When you have this, you will return an error, right? So anything that comes after this colon in Python, the next item must be indented. So, but Python in our BS code, so the next item, anything that you have this column, anything that follows must be indented. And one thing also you should remember, in function we have what we call a doc string, right? A doc string basically explains what the function does. So I have some, when I have this, for example, let me show you this. So when I create a function here, this I can have this. So docstring allows you to actually explain what the function is doing. Yes, of course, we will see this a lot. So I need to explain this. So docstring basically allows you to explain what a function is doing. So here I can say, okay, this function is adding 2 numbers, right? So this is docstring. So it used triple quote, right? Triple quote. Can you see that? So now when I run this, yeah, but what the meaning is that if I use sum here, I say, okay, I want to, maybe I share the code with another person, he will be able to see the docstring, what this function is basically using. So when I use this, like this stuff, I want to see the what actually the function is doing. This will show me, yeah, you can see this function is as in 2 numbers, right? So when you share your code or you create a package, so people will try to see what functions in your package is doing. So this will actually shows you what that is doing. In an efficient way also to show you docstring, there is a way in Python, there is one package, there is one extension called docstring. Let me, I have it. Let me show you docstring, Python docstring, what is it? Python docstring, okay, auto docstring. So this guy, basically what it does, it automatically creates docstring for you. Let me show you. So if you look at it here, let me show you what it is. So when you install, so here, this is called Python, VS Code. When you want to install some kind of extension, you come here and now install the extension. Oh, here I don't have it. Okay. Now I'm trying to install this extension called docstring. You can see 1.9 million, maybe a lot of people have installed it. So how can you use this docstring? This is how to use it. Let me show you. So here I can use this. Can you see this? Can you see it? It suggests generate docstring. Can you see that? When I tap enter, can you see it automatically generate docstring for me? So when we go to deep learning, you will see a lot of this stuff. So this thing you can see, it has argument A and B. Can you see A? Now it means I can type A is an integer. Type I can say A is integer. This is an integer, the argument. So you can see here is argument, A is an integer. You type the description, what A is, right? Which type A, what is the type of A? A is integer. Can you see that? Maybe B is double integer, and type the description that A is kada, and type also the return, what the function is doing. So you write the return type, whether the return type is integer, you write the return type is integer here. This is integer, and you say, okay, it's return what this function is returning. This returns sum of return sum of the numbers, return sum of two numbers. So this one actually, this is standard way to do Python, create a function in Python. It allows you to other people to know what you are doing. So now when I run this, you can see it will show me. Yeah, can you see it will tell the person that you share the code what kind of A is integer, and you explain what is it. And so this is called docstring. So if you want to install it, come here, you say docs, you can see it, docstring, Python docstring, and you install it. And now when you want to generate it, you automatically does create, yeah. So this is called docstring auto generator. So yeah, when you see it, yeah, you can see I just typed this triple code. Can you see that? It suggests this generate docstring, and it will automatically generate for you. Yeah, so this is called a function. Here we have a function called my function. Now, for us to use a function, is just to provide the argument. So you can see this function actually is returning these guys and returning these guys. Yeah, so that's function. This is also the something my function put to again. You can see there we actually we put the argument here to be in the function just x, y, and z. This is called default value. So you can see here we have a default value. Here we have x and y, and this x and y don't have value with them. So what this means. So here, if I come here, I want to call this function called my function. I say, okay, I give a number. X is 6, y is 6, but this guy is, I change its value. So let me give you an example. Here I just call my function, this guy, and here I don't have this number, 0.7. So here I have only 2 items, but you remember in the function definition, I have default value. So this means that this, when I run this will use the default value of z. So it will say z, what is the value? 1.5 times x is 5 and y is it will the default value. So this one, sometimes we need to provide a default value, but your default value must come at the end. In the other default value must be at the end. If your function contains default value, it must appear. You cannot have this default value. You can say, okay, y, z, and you have your y here. So you can see I have a default value maybe in the middle. So when I run this, can you see it gives me an error? So it means your default value must come, if at all your function has a default value, it must come at the end, right? So it cannot come at the beginning or somewhere else. So here you can see I provide this, but I can also overwrite it. Maybe, no, I don't want to use the default value. I can provide the another value. So this new value will overwrite the default value, right? So this is function, yeah. So you can see that's what is called you can see here I even provide 3.4147 and 3.5. This is called we have what is called what do you call it in function? So here what I mean, Malam Amurja, can you remember where the name is that you give the name of the argument? Or yeah. Okay, so here you can see that this okay, let me say the A
parameters.
No, B is equals to this, and C equals to this, Z equals to this. So you can see here, I use explicitly I use the name. Okay, I don't have A. What is the function? XY. Okay, X, Y. Yeah, you can see here I use I put the value, right? But here you can see I put them in order. X is this, Y is this, right? But I can even change this order. I can say, okay, not X. I can put this like this. X start with this, because I know I assign value to them. I can change the order. When I run this, you remember the result is this. This can still run, right? But this means that Y will still be assigned 7 and X will still be assigned 34. But if you use the default value, for example, if you use just the value here without referencing the stuff, yeah. So if you use this, it means X will be assigned this, Y will be assigned this, right? And Z will be assigned this. You don't use explicit where you put the name of the variable. I forgot this. What do you call it in function? I don't remember.
Positional arguments.
Eh?
Keyword arguments.
Yeah, keyword argument. Yeah, and the other
positional
one is
argument.
Keyword argument and positional argument. So this is called positional argument. This means that this value is assigned its position. Positional argument. This is called positional argument. Positional argument. That is, any value you assign is attached to the position in one, and this, X should be this. But if you use keyword argument, you can even interchange the way they are. So for example, as I said, I can say, okay, this one must be this, but I can have this, but I can say, okay, this is X, and give them the meaning. So you can check what is keyword, what is positional argument. There are a lot of stuff between the two. Yep. Okay, so that is functions. Yeah, so there is something called The term parameter and argument can be used for the same thing information. So there is something called parameters and argument. So in Python, there is two things. Here, one x and y, while we are trying to define a function, x and y are called, and z also are called parameters, right? But idan ka zo nan, while calling the function, 5 and 6 are called argument. Yes, these are called argument, but these are called parameters. So it's just just take the notion. The terms parameter and argument can be used for the something information that are passed into a function. From a function perspective, a parameter is variable listed inside the parenthesis, inside the function. An argument is the value that are sent to a function. So these are called argument, value that is sent into a function, but these are called parameter. But yeah, you just know them. Yeah, maybe some issues that may arise. Let's go on quickly. We have more minutes. Okay, we have 20 more minutes. Let me move on faster. If Python reads the end of a function without incontent, so a function may not have necessarily return, right? So here we can see we don't have return. So but the function basically what it does is it print the x. So when I have this, I can say, okay, call my function without return. So I put x is 4. When I run this guy will return basically 4, right? But there is no return. So what do we mean by this? So when you assign value this to result, this function we know does not return a value, but we assign it to something, to a result. Now, what do you think will result contain? What do you think the result? So this is not the result value of the result. If we try to get the value of the result, we return none. Yeah. So you cannot assign the result of a function that does not have a return value to a variable. That variable contain nothing. So the result here contain nothing. So here when we have this result, let me show you. You see that result will not return anything. Can you see result does not return it? So I try to print it is content, it shows nothing. So in essence, when a function does not return anything, but it has some side effect. This is called side effect because it's printing x. You cannot assign that return to, you cannot assign that function to value because it will not return anything. I don't know if this makes sense. Any question? Any question? Okay, let's move on. Namespace and namespace, scope, and local functions. So we have many things with what is called local namespace, scope, and scope of a function. So for example here, anything that is declared outside a function or inside a function has local scope. We want to talk about what is called local scope. Function can access variable created inside the function. So here, this is a variable created inside the function. Then we can use anything we want inside this function. Can you see that? This function A, which is empty list, is defined inside this function called func, right? So an alternative and more descriptive name describing variable scope in Python is namespace. So it means the namespace of A is inside the function. Yeah, the scope of A or namespace of A is inside the function because it is declared inside the function. So let me show us something. So here I declare a function called A, called func. And now what this function does basically, as we can see, is for I in range of 5, append is actually appending. Yeah, so here I call a function here, and you can see the function basically do some stuff inside, right? But inside this function, I have a value called A that I'm appending it is content, right? But when I say, okay, what is A? You can see A is 1 and 2, right? Is that correct? Let me say this is Z. And I append Z here. Oh, okay, no, let me, yeah, okay, let me say Z, yeah. So here I run this and I run this guy. I say, okay, what is Z? Yeah, you can see this guy give me an error. Why? Because Z, the scope of Z is only inside this function. You cannot access Z outside the function. That is, it is namespace or its scope is only inside this function. So this means that anything that you use inside a function, variable inside a function, you cannot access it outside the function. So let me show us a different implementation. So when function is called, the empty list is created, 5 elements are appended, and then it's destroyed. So when function is called, 5 elements are created, but as long as this Z, as long as the function lives outside the function, then the variable Z is destroyed. It does not contain anything. We don't have it. But let me see another implementation. You can see here we have Z, which is outside the function, right? Z is outside the function, but it's global. So when I run this guy, so can I access A now, the content of A? Now, when I run this function here, then I call A here. You can see A. Now I have the content A. Why? Because A is global. But I can access the A variable inside the function. So take this note. A global, anything that I declare outside a function is global variable and can be accessed inside a function. But anything I declare defined inside a function is local to it and cannot be accessed outside that function, right? That is what we call scope of a variable. Does that make sense? Does that make sense? Okay, so we have what we call return multiple values in a function. Another thing we should know, you can return many values from a function. So here we have a function called f, and we have inside, we have a, b, c. And we say, okay, return a, b, and c. So you can see it return anything, right? So here, when we return this, we can see, and now we set the function here. Now you see, this is the function. So here we run the function. And what the function basically doing is that it returns a, b, and c. So when we call the function, you remember this is how you call the function, right? But this function does not contain any argument. So when you call the function, we can assign a value because it returns 3 items. We can do this assignment. It means this function will return 3 items. The first one will assign to A, the second will assign to B, the third will assign to C. So this is basically, when we run A, we can see what the value is here. So this is value. Yeah, you can see A is 5, right? But remember, why is this so? Remember this, who can tell us this? What is this? What this is? Who can tell us what this is returning? What is this?
It's a tuple.
Yawa. This is a tuple. So this is in some way like this, explicitly, right? This is explicitly. I remember we use what we talk about what is called tuple unpacking. So this means it's returning this. So this means it's returning this. We assign this to A and B. Remember what we discussed about tuple unpacking, right? So what is happening here is that the function is actually just returning one object, a tuple, which is then being unpacked into the result variable. So let's assume that we don't actually assign the result to 3 objects, A, B, and C. We assign only to one object, which may be return a value. So we call f, and now when we call f, it will just return 3 values. Can you see that? Yeah. So this is some stuff like that. This is the same implementation, but I use the explicit tuple representation. Yeah, you can also return a dictionary. So you can see this is a dictionary, and you can return. Yeah. Any question before we continue? How many minutes do we have? We have 12 minutes. Any question? Okay, so let's go on. So functions are objects. So since functions are objects, we are still on function. We are looking at a lot of other things related to functions. Here they said functions. So here, for example, I have a list that contains a list of items. But in data analysis, sometimes you want to do cleaning. So it means maybe I want to remove hash. I want to change them to remove a space. You can see a space. You can do this with what is called reg, module call for regular expression, right? So now I can say import regular expression, and now create a function, define clean string, and say, okay, input my string. I define a function that do this, the cleaning. I can say, okay, result, I create an empty list, and now I can go for loop. So for value in a string, right, I will put a string, then value is equal to value dot strip. It means I'm stripping if there is any cells, and here this I'm removing comma. Remember, we have not done actually regular expression, but we'll do that. But maybe you may not understand this. I may need to skip this one, I think, because we have not done regular expression. It may be a little bit confusing. But what is basically just the idea is that here we want to remove some stuff, clean this thing, but we can create a function. Can you see the name of the function is called clean string, and all the all the stuff that we want to do the cleaning, we can do it inside the function. So what are the things we want to do? Number one, we call the name called clean string. The first thing we want to remove space. Now, how do you remove space in Python? We want to iterate because we have many operations that we want to perform. So we want to use for loop. So the first thing is for value in string. So for any value, 1, 2, or whatsoever, remove string. As strip, value the strip, remove any white space. Here, sub is a regular expression that removes the comma. Title, it means this, return this, change this to be in title, that is in capital for in title case, and result appended value. The last one here, you can see, because we create an empty list, we are appending, we are adding more item to the stuff, and finally we return a result. So let's look at what will this happen. And now when we call our function called clean string, and now we have our object called state, and now we pass into it. Can you see that? Now when we run this, can you see it basically clear everything? And it is now in, it performs, you can see it removes the comma, it removes the, all spaces, it changed this one in Florida, it removed this hash, So these are some of the stuff we'll see, but what they are saying is that the best way to do this is, there is one way to do this, is basically to create a list of functions. So here you just declare one function. I create a function called remove punctuations. This is what it's doing. This is a function that removing punctuation. Now I put all the function inside a list. String the strip. This remove the white spaces. This is a removing punctuation. This is string title. So what you need to do is to create a list, and now I apply that list of functions inside a function. I don't have much time. We have 8 more minutes. Maybe I can skip this one, but the main idea, you can read it. Yeah, this is anonymous or lambda function. So anonymous or lambda function is another stuff that we do in Python, which basically does not return, does not have a name. We don't actually specifically define the function. So this is where we create a function in Python, def short, we create a function. Basically, it returns the square of a number. So when I have this short, it returns the square of it, right? But we can do this in what is called anonymous function. What anonymous function does, this is how we do the anonymous. You use a keyword called lambda. The input you put here in your function, you use it here, x, and you put this semicolon, and now you put your expression here. And now you have this, some stuff like this, equal to, you assign it. So this is called lambda function. Lambda function, Python. I don't have a better graphics. Yes. Okay, yeah, something like this. You can see lambda, then you put your argument. Remember our argument in the defining function, then the operation you want to do. And here, yeah, this one is much better, I think. So here, this is the keyword lambda. You can see my browser, right? Can you see my browser?
Yes.
Okay, this is a keyword lambda, and this is the argument of your function. this is one line expression, and this is function object that accept and store the result. So you can store the result here. So for example, here, if you look at it, this is function name, this is the argument. So your argument is X, you put it here, you put this column, this expression that return, you put return. Here, you don't need to put return, you just put this X times this, and now the result will be stored here. So you put this one. So let's do the same thing here when I say this. So now this is a lambda function. Now, when I want to do the same calculation, I can say equivalent. Now I can provide the argument, which is X3. Now we'll do the same thing as we have with this function, the normal function. So this is called lambda function. This is called anonymous because this function does not have a name. So we use it sometimes when we want to return something. Yeah. So this is very important. For example, here, yeah, any question regarding the lambda function? Any question regarding the lambda functions? Any question?
Lambda function.
So if you have number of arguments,
if you have
maybe more than one or two.
Yeah. So if I have, for example, here I have x, y, right? I have x, y, 2 arguments. And now here what I'm doing, I'm multiplying x and y, right? So I'm multiplying x and y. So here I have 3 arguments. So if I run this, here I have this multiplication of 2 arguments, right? 12. Now here, if I'm doing lambda, so I can put my x and y. Here, can you see them? Now I can use x times y, and now do this. Can you see that? Now I can put another argument here, and this, and now, yeah. Yeah, can you see that? This is called lambda, anonymous function. Let me show you the example. Lambda function are especially convenient in data analysis, and it is often less typing and clearer to pass a lambda function as opposed to writing. So there are quite example here. Let me show you the advantage of it. So here I create a function here. Can you see what this function does? Who can tell me what this function is doing? This function, what is it doing? What this function is doing?
So it is related to another function f.
Okay.
So it iterates through some list, then it extracts every element in the same some list and submit it to f function and then return the value.
Okay. So this is a function. This is a method. Method. I said it's a method. Function. Basically that create some list. It takes some list, and f is maybe method or something like that. And what we do basically is that for x in some list, apply this function on the item, right? So how can we do that? So for example, here I have integer. Here I have this. Can you see that? I have some integer 400. Now I can do this function, apply list. This is my integer. You remember what this function does? It takes in some list, which is this. And now function, what this function is this? So instead of for us to create a function, we can pass now anonymous function. This function, basically what it does is given any number, it will return the square. So this means that here for any number in this, apply the function. The function is taking the square. So here lambda function is anonymous.
It's twice.
Yes, it will be twice. So you apply now lambda function. You can see now you use one liner to apply to any item in the list. I don't know if this makes sense. Angani kwa? Malam Amrja, wannan ku angani kwa?
Angani, doctor.
Nur. Okay. Abdullahi, angani kwa? If O is confusing.
The lambda is a little bit confusing.
Okay. Yeah. So do we have more time? Oh, we have 1 minute. Yeah. So I think we have because this chapter is basically doing a lot of we are doing a lot of complete Python background. So it's actually taking us time. So maybe we can stop here because it's time for prayer, I think. Let me see whether we can find a better place to stop. Yeah, so I think let's explain the lambda clearly. Maybe let's go one more time. Yeah, from here you understand here. Yeah, we said this is way to define a function. Right. Right. We define a function. We use the keyword, but we said we can write a function with lambda in a lambda approach, which is called anonymous function. So for us to do that is basically, as I showed here, it's this. You set a lambda, which is a keyword. You provide your argument, and now the operation you do. So for example here, this is a function, right? Normal function. What are the arguments? X and Y, right? So if I'm using lambda, what I will do is I provide lambda, and I put the argument here, A and X and Y. And now whatsoever I do here, which is X times Y, and now I put it after the comma here, which is A times A. This is the argument. And now the result of this anonymous function, you can store it, or you may not store it if you don't want to store it. So if you want to store it, then you can have this stuff and now apply the function. So here, this is what we implemented. The lambda, you can see the argument, and this is the expression. And now we have this return function object that accept and store the result of the expression. Function object. So this is function object that accept and restore the result of the expression. So it accept and restore the result of the expression. So now here we can put the argument here. Remember, if we create a function using this, we call the name of the function here and put the argument inside, right? But if we use anonymous function, then here where we store the value, it is something as well. Where we store the value here, we store the value here at equivalent, here equivalent and this, then this is where we can call the function. So here we call the function and we provide the argument, and it gives us the same result. But in some situation, you may not actually return the result at this and save them. This is a situation where we give where you may see them in the future. So here we provide an example. Here we create a function called apply to list. And here the input are some list and function. This means that what is returning is this. For any item in the list, applies the function. We use this is a list comprehension. For any item X in the list, apply the function that you supply. So here we give an example here. We call the function, we have a list here, and now we call this function int. This is the list, right? And now apply the function. What is the function here? Lambda this. Since we are not storing the value, this is a convenient way. We don't return. So apply this function, just anything, take any integer, multiply by it. We are not storing because this function apply to list ultimately return the square. So this is one way. Yeah. So we can do that. Yeah. So I think we can stop here. We can continue here next week because there are some important concepts we can discuss, which are basically called generators. Generators in Python, which are very good thing we should know. So we can actually finish generators next week, and at the same time next week we can start doing the NumPy. Yeah. All right. So I think we can stop here. Any question or no? Okay. So see you. If there's no question, see you next week. We can continue with the chapter, and we continue at the same time with NumPy next week. Bye-bye.
Thank you.
Thank you.